Well, what are we looking at here? Hopefully not, because this is a Hawker 800 and ASG 29.
But that was the
Before and after. And if you haven't seen these pictures, radar dome is gone. This is the remains of the spar of the ASG 29, and this is other end of the spar of the ASG 29 in the cockpit. Okay, that happened at about 17,000 feet out in Nevada. So, while you were flying, emphasis on see and avoid. Basic concept is you want to be looking outside of the cockpit. If you're looking at your instrument panel, you're not going to see another aircraft. We've got some challenges, particularly when we're in training aircraft. Instructor sitting in the back seat, the experienced pilot sitting in the back seat, student sitting in the front. What can the pilot or the instructor see? Particularly in the Linux.
The student in the front seat.
You can see the student in the front seat. You can see the wing. Not much else. Student in the front seat has got a much better view. You've got to be looking out for other aircraft. Psychological issues, blind spot. We all have a blind spot. If you haven't gone through the exercise to find that blind spot, it might be worthwhile doing. What is empty field myopia? When you are scanning out of your cockpit looking for other aircraft, what is one of the challenges that you face, particularly on an overcast day where you can't see very far? You're looking out. Where are you focusing? Focusing about 6 feet away. If you're looking at a blank sky where you don't have any detail that you can pick out, your eye is going to naturally focus about 6 feet away. And are you going to see that aircraft that's 3 to 4 miles out? Distractions, flight computers, variometers, things that are going to draw your attention into the cockpit when you should be looking for other aircraft. Last thing I added on here, active situational awareness. Most accidents are going to be within 3 to 5 miles of the field. If you're flying locally, you need to be paying very close attention to what's going on at the field. What aircraft are up flying? Where's that tow plane? What's the tow plane doing? You saw a tow plane on the ground 3 minutes ago and it's not there anymore. Where is it? That situational awareness is going to help you keep track of many of the threats that are in the area. Knowing where the drug ships are, knowing where people are on the bridge is a big step towards helping prevent a mid-air. Running into another glider halfway between Blacksburg and Newcastle, that's an accident. Running into one over the bowl is not. Known hazardous areas within 5 miles and 3,000 feet of an airport. Approaches into Rona, near NavAge reporting points, Victor Airways, low-level routes. We had a C-17 over recently. We've got high-speed aircraft over every now and then.
We had a C-130 2 weeks ago fly by about 300 feet off the end of the...
Lovely. Okay, known specific areas, hazard areas for gliders. Well, number one, the local area, right around Newcastle. Normal tow patterns. If you are flying in a normal tow pattern along the ridge top through the gap, you should definitely be looking out for the tow plane unless you know exactly where the tow plane is. Cumulus clouds, thermals. You find a thermal, guess what? Everybody that's flying around you sees you circling, and what are they going to do? They're going to come join you. How many pilots have been surprised by another glider in a thermal? Big surprise occasionally. Ridge top, another area that's going to concentrate a lot of traffic. Turn points, start and finish gates. Any others? So how do we look for other gliders, other aircraft? Visual scanning. Looking straight at something, you're not as likely to catch motion as just a little bit off to the side in your peripheral vision. You use that center focus of your eye to help pinpoint or identify what you're looking at, but the peripheral vision is a little bit better at catching the motion, and that's the only thing that you really can rely on to see another aircraft. Proper scanning technique recommended by advisory circular. Looking in 10-degree segments, stopping every second or two to focus in one area to see if you can catch any of that motion. Threats, where are you going to find an aircraft that's an actual threat to you? Generally within about 3 degrees above or below the horizon, so there's no use in looking up there for an aircraft.
And it's not going to be moving.
It's,
One that's in the ditch is not going to be moving the windscreen.
that's another challenge. We're going to take a look at that in a second. And don't forget to remember to focus on the horizon versus focusing out in space. Reaction time. If once you recognize that there's an aircraft out there in your scan,
Clear RMH on the available.
953 clear, on the available, 19.
if you break up the forward half of the horizon into 10-degree segments, you're really looking at about 18 different segments. And if you're going to spend 1 to 2 seconds per sector, you're looking at a full scan that's going to take anywhere from 18 to 36 seconds. So how long does it take you to scan the area around you? Once you see something, how long does it take you to recognize that it's an aircraft? Become aware of what it's doing, probably about 5 seconds to figure out, is that aircraft moving across the sky or is it staying in one location? Of course, if it's staying in one location, it's going to be even more difficult to pick out. Then you've got to make a decision. How do you avoid? Another 4 to 5 seconds there. Going to take you a little bit of time to react, and then the aircraft is likely going to respond after about 2 seconds. So once you see an aircraft that turns out to be a threat, quickest you can respond is about 12 seconds. So total time we're looking at here about 20 to 48 seconds. Now, time to impact. This is out of Advisory Circular 90-46, I believe. Thought I had it on here, but must have taken it off. Standard issue Air Force T-33 trainer aircraft. What does it look like at 10 miles? What does it look like at a half mile? Dropping down, distance. Could be moving at different speeds. So we're not likely to run into anything where we're flying at 600 knots. 360 is a little bit fast as well, so I added a couple of columns here for 250 miles an hour and 125 miles an hour. Looking at 250, something moving fairly fast through our airspace, 4 miles out. This is what it's going to look like, and it's going to hit us in 58 seconds if we don't do something. Cessna, we're in a little bit better shape. It's going to be a little bit bigger when it's 58 seconds out. 2 miles. This is worth thinking about in conjunction with how long does it take you to scan the sky, how long does it take you to react. Reaction time, you've got the 12 seconds there in yellow. You've got the scan, the time that it takes to scan the sky in gray. Now, is a collision imminent? Got a couple of slides here. See anything? 10 miles out. 8 miles out. Moving closer mile by mile. We have a threat. Which one's the threat? Why?
Hey, front passenger, put your head out of the way.
That's your student. That's the student pilot in front of you.
Look at the airspeed.
So, threat? Why not? It's moving. Getting a little closer.
Look at each other.
Now we're in a problem because this aircraft is moving fast enough, it's getting close enough to us that we're rapidly running out of time to react. But the thing's not moving across our sky, it's not attracting our attention.
Control, station 8.
We're probably watching that one that is moving. Now we've got a dropping missile here. And
Station 8.
welcome.
Bridge 82 is in service.
Another area to watch out for, ridge soaring. Rules of